Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. Yeah. So let me start with my introduction. I am Jeetendra Dixit. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. I teach mathematics and we were doing differentiability, all right. So I'll continue that and I'll tell you some remaining important points related to differentiability today. But before we begin, let me tell you about the Unacademy subscription. So you can buy, if you're preparing for IIT-JEE, then you can buy two types of subscriptions on Unacademy. One is Plus subscription, in which you get unlimited access on the platform. You can watch the live sessions of any educator who is teaching for IIT-JEE, all physics, chemistry, and maths. Hello, Subhashri. And quizzes will also be accessible to you, and if you miss something, you can watch recorded sessions. Every session is recorded, so you can watch them later, even you can download them and watch them offline. Good afternoon, Subhashri, how are you? And second is these are the subscription charges for Plus. You can buy for 1, 3, 6, 12 and 24 months, and you get 10% discount using a code Jeet1. You can use this code and you'll get 10% discount. So these are right inside, you can see the discounted price. Second is Iconic subscription, in which you get a personal coach, all the benefits of Plus, and apart from that you get a personal coach who will guide you throughout your preparation for top exams like IIT-JEE, Advanced, Main and BITS. And your test analysis will be done in a personalized manner. Personalized feedback will be given to you to manage your time and exam approach. Study planner, your preparation, your study planner will be customized and bi-weekly reviews will be given to you. All right. These are the subscription charges for Iconic. You can buy for 1 year in 56,000 and you get 10% discount also, and 2 years in 86,000, and again you'll get 10% discount. This is Unacademy's learning app, which you can download from Play Store, and after downloading it, you can start special classes which are completely free. So you can watch any unlimited special classes on the platform every day. Many educators are taking special classes, so you can watch special classes for free, okay, without taking any subscription. And through special classes you get to know how interactive these classes are. You can ask your doubts during the class only. You can chat with your educator. You can participate in poll. All right, so many features are there. It's very interactive platform. So just download this app, make your account and start learning. All right, now we will begin our session. So we did this part of differentiability yesterday. All right. So first I'll tell you how to solve the functional equation using differentiability. Say find fx if it satisfies f of x plus y is equal to f of x plus f of y. All right, it's a very simple equation. You know the solution, but we'll do it using differentiability and many other equations also apart from that. So we are learning the concept first of all. The f is a differentiable function. F is a differentiable function, okay, so obviously continuous. We need to find fx, and f of 1 is given 2. All right, f of 1 is given 2. So see how to do it. Or you can say f dash 1 is given 2, okay. All right, f of 1 will work. Hmm. So see, let's learn the process first of all. First principle. So f dash of x can be written as f of x plus h minus f of x divided by h. In this, f dash is not given. Generally, f dash of some value is given in such questions. This is h is approaching to 0. This is called f dash of x because f is a differentiable function. So you can write f dash x is equal to this, right? So you can use first principle or the other method I'll tell you after this. So using this, you can write f dash of x is equal to, now use this value, f of x plus h is given. F of x plus y is f of x plus f of y. So using that, we can write f of x plus h is equal to f of x plus f of h minus f of x, right? And divided by h. Now this term will get cancelled, all right? So you'll get f dash of x is equal to f of h divided by h, all right? Now from this, you can find, you put x is equal to y is equal to 0 in the original equation. So f of 0 generally we find from the given equation by putting x is equal to y is equal to 0. Generally we get it. So f of 0 is equal to twice of f of 0. So that will give you f of 0 is equal to 0, okay? Okay, what is the use of this? See, if I write, because we know f of 0 is 0, so we can write this f of h minus f of 0, which is 0 actually, divided by h. H is approaching to 0, all right? You can apply this condition here only. Now this term is basically f dash of 0 because f dash of 0 is f of 0 plus h minus f of 0 divided by h, all right? So you can write f dash x is equal to f dash of 0, which is a constant basically, right? So you can take f dash 0 is equal to constant because it is not given in the question. Generally they give the value because in this it might not be required, so it is not given. So all right, no problem. We will treat this as a constant. So we can write dfx. Now we have got this simple differential equation, dfx upon dfx is equal to f dash of 0. Then we can integrate it. So we'll get fx is equal to, take dx to right hand side, right, like this. dfx is equal to f dash 0 into f dx, all right? So now we are integrating it. After integrating, we'll get f dash of 0, into x plus some constant, okay? So now f dash of 0, because f of 0 we know, okay, we know two values, f of 0 is 0. So if I put in this, f of 0 is 0, then c will be 0, right? C must be 0. So we will get this equation, f of x is equal to f dash of 0 into x. Then another value was given, f of 1 is equal to 2. So if I put x is equal to 1, this will be 2 and this will be f dash 0 into 1. So we'll get f dash 0 is equal to 2. So finally we have got this function fx is equal to twice of x, okay? So this was the method using first principle, okay? We solved this differential equation using first principle. I'll tell you another method, but we will learn first this. We'll solve questions using first principle and then we will learn another simple method, which if we use that second method, then we'll reach to this fifth step directly. I mean f dash this step. We'll reach to this step directly, okay? I mean we can reduce 2-3 steps by applying that method. All right, so have a look, see if it is clear, let me know. Alright, so I'll give you another equation to solve. Then solve this equation. F of x plus y is equal to f of x into f of y. Okay, now this is given, and f is a differentiable function. These are standard equations. I mean, functional equation of standard curves. So f is a differentiable function. All right, and f of 1 is given 2. Again, solve it. Solve it using first principle only. So f is a differentiable function. F of 1 is equal to 2. Well, let's start with this. F dash of x is equal to, because f is a differentiable function, so you can again write that f of x plus h minus f of x divided by h. H is approaching to 0. All right, so f of x plus y is equal to f of x into f of h in this case minus f of x divided by h. Now f x is not cancelling, but you'll get this f of x into f of h minus 1 divided by h. Okay, now see, f is a differentiable function, and f of 1 is given 2. So if I put x is equal to 1 and y is equal to 0, I'll get f of 0, right? Let's see. So if I put f of 1, if x is equal to 1, y is equal to 2, then I'll get f of 1 is equal to f of 1 into f of 0. f of 1 is given 2, right? It's not 0, so you can cancel f of 1. So you'll get f of 0 is equal to 1. So like in the previous example, you're getting f of 0 again, in this case 1. F of 0 is 1. So you can write this number is equal to f of 0. So you can write f of x into f of h minus f of 0 divided by h, which is nothing but f dash of 0. So it is f dash of 0 into f of x is equal to f dash of x, alright? Then you can integrate it. This is dfx upon fx, right, is equal to f dash 0, which is a constant, f dash 0 into dx, all right? So integrate this, write this constant outside. So it is going to be ln of fx is equal to f dash of 0 into x, all right? So you can write this fx is equal to e raised to plus c integrating constant also. Now e raised to f dash 0 into x, and plus c you can write e raised to c separately, all right? And e raised to c you can write f of k. E raised to c you can take k, some constant k into, and this also I'm writing like this, e raised to f dash 0 whole power x. So I can take e raised to f dash 0 as some other constant a, all right? So I'll get something like this, a into k into a raised to x, all right? Now we need to find these two values, k and a, all right? So we know two values, f of 0 is 1. So first we'll put x is equal to 0 and f of 0 is equal to 1. So use it, 0 is equal to k times of a raised to 0. So from this we'll get k is equal to 1, all right? Now second, so now we have got fx is equal to a raised to x. Now this value is given f of 1. So if I put x is equal to 1 in this, I'll get 2 is equal to a raised to x, a raised to 1, I'm sorry, x is equal to 1. So I'll get a is equal to 2, right, from this. So finally I've got this function fx is equal to 2 raised to x, all right? I hope it is clear. So in this way we can solve these equations. This is the proof. I'll give you another equation to solve. Although you know, because these are a functional equation of a standard curve, so you can generally we remember it. So I'm telling you the proofs of these equations, and later we can use these use this method to find the function in any given functional equation. So the next one is this, f of xy is equal to f of x plus f of y, you know the function, right? Where x and y are positive numbers and f is a differentiable function. Differentiable function such that f of 2 is equal to 1. Now let's do it. All right, so now let's discuss this. Because f is a differentiable function, so we're going to start this. F dash of x is equal to f of x plus h minus f of x divided by h, where h is approaching to 0. Now we will use this equation, but how to use it? So this one is a tricky one, and I'll see how to use it. Well, you can take x common, okay, from this. So you can write x into 1 plus h upon x, okay, in this way, minus f of x, all right, and divided by h. Now you can write this f of x into this, you can write f of x plus f of 1 plus h upon x, all right, minus f of x divided by h. Now you can see this will get cancelled, f of x, then h is approaching to 0. So you can write f of 1 plus h upon x. Now first of all you need to find f of 0. So put x is equal to y is equal to 0, and clearly you can see f of 0 is equal to twice of f of 0. So you are getting f of 0 is equal to, and by the way, f of 0 is not defined because x and y are positive, so you can't use it, okay. So the other thing which you can use is, say x is equal to 1 you can use, yeah, and yeah, x is equal to 1 you can use, and y is equal to maybe 2, or maybe x is equal to y is equal to 1 will work. So yes, f of 1 is equal to twice of f of 1. So you're getting f of 1 is equal to 0. Simple. Okay. So you're left with this much, all right, which you can write f of 1 plus h upon x minus 0, because 0 is f of 1. So I'm writing f of 1 divided by hy. Because if I divide by x and multiply by x, then this can be written as, because h is approaching to 0, so h upon x will also be approaching to 0. X is a non-zero number, all right. So this can, the h upon x can be treated as delta, all right. So you can read this as f of 1 plus delta minus f of 1 upon delta. Delta is approaching to 0, which can be written as f dash of 1, okay. So now you will get this functional equation. F dash of 1 is equal to, sorry, f dash of x is equal to f dash of x is equal to f dash of 1 into x, all right. Now you can integrate dfx upon dx. You got f dash of 1 into x into dx. Integrated, so you'll get fx is equal to, uh, wait a minute. Oh, I'm sorry, this x will be in denominator, not in numerator. This was a mistake. So x here will be 1 upon x. Alright. So it is dx upon x, basically. So if you integrate it, it is going to be f dash 1 into ln x, alright, f dash x. So f dash of 1, I'm sorry, f dash of 1. Now you need to find f dash of 1. How to find f dash of 1? You can use this n plus integrating constant also. You know two values, f of 1 you know, and f of 2 you know. So if you use f of 1, put x is equal to 1. So f of 1 is equal to 0. So 0 is equal to 0 plus c. So you'll get c is equal to 0 first of all. Then you'll get fx is equal to f dash 1 into ln x. Now you need to find this constant, f dash 1. So you can use 2. Okay. Fx is equal to, x is equal to 2. Put x is equal to 2 in this. So you'll get 1 is equal to f dash 1 and ln 2. So f dash 1 is equal to 1 upon ln 2, all right. So finally, if I write fx here, fx is going to be ln of x divided by ln of 2, which you can write log of x base 2. So this is your fx, log of x base 2, all right. All right. So I'll give you next functional equation, which is f of x plus y by n is equal to f of x plus f of y divided by n for all x and y belonging to real numbers, and n is not equal to 0 comma 2 if f dash of 0 is equal to k. Right, a finite quantity, k is a finite quantity, then find fx. And f is a differentiable function. Okay, f dash 0 is given, f is a differentiable function. Now solve it. All right, so let's begin this. We have another method. Now here I'll tell you the next method. Rather applying first principle, you can directly differentiate this with respect to x or y. And the differentiation will be partial. You are differentiating with respect to x, then y is a constant. You can say it's a partial differentiation type. Okay, because x and y are independent. So if you're differentiating with respect to x, y will be constant, and if you're differentiating with respect to y, then x will be constant. Now, second step is you can see in such equations f dash of something is given, like in this case f dash of 0 is given. So the variable with respect to which you are differentiating will put that variable is equal to 0, and the other variable you will, if it is x, you'll keep it x. If it is y, then replace it by x. Okay, so that equation will look the function equation in x. All right. Like in this case, I'm differentiate with respect to y. So you'll get that differential equation which you are getting by applying first principle, the same differential equation. Okay? It's the same thing. So I'll tell you both the methods. So differentiating with respect to y, you'll get f dash of x plus y divided by n into differentiation of x plus y by n, which is 1 upon n. Okay. The differentiation of fx upon n is 0 because fx is a constant with respect to y, and differentiation of f of y is f dash of y divided by n. Okay. Now, as I told you, the variable with respect to which you are differentiating, you need to put that variable is equal to some constant whose value, derivative at that point is given. Okay, like f dash of 0 is given. So you need to put y is equal to 0 in this. Okay, so we'll put y is equal to 0. So put y is equal to 0, and because the remaining variable is x, so keep it x only. So now I'll get this differential equation 1 upon x, f dash of x upon n is equal to f dash of 0 upon n. This n you can cancel, and f dash 0 is k, so you can write k. Now f dash of x upon n is equal to k. You have got this, right? So you can replace x upon n by new x, or capital X you can say. Okay, so you can write f dash of capital X is equal to k. Now you can integrate it. So you'll get fx is equal to kx. All right, simple differential equation plus c. And to find c, you can put x is equal to y is equal to 0 in this equation. So you'll get f of 0 is equal to twice of f of 0 divided by n. So you'll get f of 0 is equal to, n is not 0, n is not 2, so you will get f of 0 is equal to 0. All right, simple. So this c will vanish, and finally you'll get fx is equal to kx. All right. So in this case, you don't need to apply first principle. You can use this method, okay? And use this method, and directly you'll get the differential equation which you were getting by applying the first principle. Okay, so this is another method, another way. The first method is, more sophisticated. Like if you're writing the subjective exam somewhere, then it's advisable to use that particular method in which you are using first principle. Okay, this is kind of a shortcut, okay, to get the differential equation. All right, so I hope I'm clear. In objective, you can use this method. So now I'll give you another differential equation, okay, which you can see. Yeah, the previous one you can do using first principle also. Let me tell you, f of x plus y divided by n was given f of x plus f of y divided by n. Okay, so I'll do that method too using the first principle. So you can use f of f dash x is equal to f of x plus h, all right, plus minus f of x divided by h, and this you can treat as, okay, you can write this f of nx upon n plus nh, all right, is minus fx divided by h. Now you can use this equation, okay. So this is your x and this is your y. So you can write this f of nx plus f of ny divided by n minus fx divided by h, all right, like this. So nh, not sorry, nh. So then you can use this f of nx minus nfx, all right, and plus f of nh divided by h. Okay, now you'll have to do some manipulation to get the same differential equation which you are getting earlier, like in this case. Yeah, f dash of x upon n is equal to k constant. So to get that, this is f of x upon n. All right, wait a minute. All right. So f of 0, we have already got 0. F of 0 was 0, right? So using that, you can write, keep this as it is. F of nx minus minus n times of fx. You can see in this method you'll have to do manipulation. You'll have to work hard to get the differential equation. But in previous method you got the differential equation easily. Plus you can write f of nh minus uh, minus okay, this is n also, minus f of 0. You can use directly f of 0 divided by whole divided by h. All right. Now see, in this equation, if I put y is equal to 0, again this equation put y is equal to 0, so you'll get f of x upon m is equal to f of x upon n, right? And if you replace x by nx, then this equation will be, this equation actually is going to be f of x is equal to f of nx divided by n. So cross multiply, so you can see these two terms are equal, so you can cancel these two terms here, right? And after cancelling them, you can write f dash x is equal to, this is what, because this is nh, h is approaching to 0, so this is 0 plus delta minus f of 0 upon delta. Okay, n is a finite number, so you can write this f dash of 0. So you have got the similar differential equation which you were getting here, right? The same equation, f dash, this is kf, f dash x is equal to k now. So now further you can simplify. So this much manipulation you have to do, okay? And which differential equation where you have reached now, you directly reached here, right? Without putting any extra efforts, directly differentiate and put y is 0. I'll give you one more example based on this, okay? So now you solve another differential equation. So if e raised to minus xy, f of xy is equal to e raised to minus x fx plus e raised to minus y f of y for all x, y belonging to R plus, and f dash 1 is equal to e, then find fx. Find fx, where f is a differentiable function for all x. All right. Now try this particular question. So you can use any method. You can use first principle or All right, let's discuss it. So as I told you, we can apply first principle or we can directly differentiate it. So I'm using the direct differentiation method. So because this equation is symmetric in x and y, so you can differentiate with respect to any variable, x or y, doesn't matter. So differentiate, okay, differentiate with respect to y. So differentiating with respect to y and putting y is equal to some constant. Which constant in this case we'll put? Y is equal to 1 we will put after differentiation because y dash 1 is given, all right? So differentiate it. Differentiation, use u into v formula. X is a constant, all right? Remember, when you're differentiating with respect to y, x is a constant. So it is e raised to minus xy into f dash of xy, and because you are differentiating with respect to y, so differentiation of xy is x plus. Now f of xy as it is, and differentiation of e raised to minus xy. So e raised to minus xy into differentiation of minus xy is minus x. All right, so I'll remove this minus x. All right. So now is equal to right hand side, it is going to be e raised to minus x. Okay, this is going to be 0 because there's no term of y. So plus, this is completely 0 because all terms are functions of x and x is a constant with respect to y. So differentiation of this with respect to y will be 0. Now we'll differentiate this. So e raised to minus y into f dash y plus f of y, e raised to minus y, differentiation of e raised to minus y is e raised to minus y into differentiation of minus y is minus 1. Okay. Now we will put y is equal to 1, okay, as given in the, this value is given, f dash of 1 is given, so we'll put y is equal to 1 in this case. So by putting y is equal to 1, we'll get x e raised to minus x f dash of x minus x f of x and e raised to minus x, all right, is equal to yeah, e raised to minus 1 f dash of 1 minus f of 1 e raised to minus 1. This is what we are getting, right? All right. Now see what value is required. F of 1 is required, right? Okay, we'll get f of 1 by putting x is equal to y is equal to 1 in this equation. So in this equation, if we put x is equal to y is equal to 1, we'll get e raised to minus 1 f of 1 is equal to e raised to minus 1 f of 1 plus e raised to minus 1 f of 1. So e raised to minus 1 cancel and f of 1 will be 0, right? So this term will vanish. F dash 1 is given e. So if you put e, so e upon e, this will be 1, okay, 1, and you'll get this differential equation. Let me write it. So f dash x, and you can multiply by e raised to x, minus x fx is equal to e raised to x, all right? This. So this is the differential equation which we are getting. Now you can simply write in terms of yes. Now this, what kind of differential equation is this? Do you know? Let me write like this: dy by dx. This y is not the y which was given in the original equation. This is y is equal to fx. Okay, y is equal to fx wala y. Okay, so f dash x, you can write dfx upon dx, or I am writing dy by dx. So this y is equal to fx. Okay, divide by x will get minus y is equal to e raised to x upon x. So you know this is a first order linear differential equation. Okay, this is first order linear differential equation. So you need to multiply it by integrating factor. Do you know? So what is the integrating factor of this? If you remember the integrating factor, then integrating factor is e raised to integral of coefficient of y, which is minus 1, okay, dx. So it is e raised to minus x, okay, e raised to minus x, the differential equation, which was there in the original question actually. This is exact form. You can write this derivative of something, okay. All right, so okay, okay. I'll use this one. Okay, I'll use this exact form. It's better. Although this is a proper method which I was doing, but I've got this exact form here, so I'm just doing that. Okay, at this step, what were we supposed to do? If you can, somebody who has not done differential equation, how would he solve this equation? He can take x common and he can write e raised to minus x f dash x minus fx e raised to minus x. So that person can figure out that this is nothing but the exact derivative of fx into e raised to minus x. He can write like this, and divided by dx is equal to 1 upon x. All right, and then you can integrate. So then you can integrate, take dx to right hand side. So like this, then you can integrate. So you're integrating 1 with respect to this function. So you'll get fx e raised to minus x is equal to integration of 1 upon x, which is minus, which is ln x plus c. All right. Now c you can find. F dash 1 is f of 1 is 0. So if you put 1, then c is going to be 0, right? So c is going to be 0. And finally, you'll get your fx. Fx is e raised to x ln x. This is your function, all right? This was the answer. So I hope it is clear, huh? Okay, one last question, last sum I'll give you for today's session. Okay, this is different from differential equations. We have understood the method, so you can now solve the differential equation. This is IIT-JEE JEE 2000 question. So in this, px was given a naught plus a1x plus a2x square and so on up to an x raised to n. This was pn, okay? And mod of px was given less than or equal to e raised to x minus 1 mod minus 1 whole mod for all x greater than equal to 0. Then prove that a1 plus 2 a2 plus 3 a3 and so on n an mod is less than or equal to 1. All right, so this is what we need to prove. So this is our last question of differentiability. All right, we'll end it here. All right, then let's do it. First of all, you need to figure out what is this. If you differentiate px and put x is equal to 1, if you differentiate px, p dash x is going to be a1 plus 2a2x plus 3a3 x square, right? And so on, and an x raised to n minus 1. And then you put 1, so p dash 1 is going to be this value, a1 plus 2a2 plus 3a3, which is not very difficult to figure out, okay? If you think about it, then you'll get it, p dash of 1. So basically we need to prove that p dash of 1 is less than or equal to 1 mod of. Okay, this is what we need to prove. Let me check my voice first. Nice. Okay, so we'll do that. Now see, what is p dash 1 by the way? P dash 1, because px is a differentiable function. So p dash 1 is p of 1 plus h minus p of 1 divided by h. Okay. So first of all, let us use this equation. Mod of px is given less than or equal to mod f. Obviously, you'll have to use this, okay, to prove the given. To prove the given inequation. So we'll put x is equal to 1 plus h in this, okay? Let's see. So it is p of 1 plus h, all right? And mod of that is less than or equal to, it is e raised to 1 plus h minus 1 is h minus 1. Okay, so we have got this equation. Now second, to make p dash 1, we need p of 1 first of all. So how to find p of 1? We'll use the same relation, okay? In this relation, put x is equal to 1. So if you put x is equal to 1, you'll get mod of p of 1. Obviously from first equation also, but that will be a0 plus a1 plus a2 up to an. But we don't know the value of that. So I'm using the second given inequation relation basically. So if I put x is equal to 1 in that, I'll get p of 1 is less than or equal to e raised to 0 minus 1, which is actually, you can see 0. So p of 1 mod is less than equal to 0. So mod of anything can't be less than 0. It will be equal to 0. Okay. So it is p of 1 is equal to 0. So that was the main point. So if I write p of 1 plus h minus p of 1, because I'm going to use this formula. So p of 1 is 0. So I can subtract p of 1 less than equal to e raised to h minus 1. Now you can divide by h both sides. H is a positive number. Okay. So you can divide by h. H is a positive number. H is approaching to 0. Or you can divide by mod of h. Okay. If you have any doubt. So mod of h will be positive. Now you can write this expression as p dash of 1 mod, all right, p dash of 1 less than or equal to, this is e raised to h is minus 1 upon h, h approaching to 0 is 1, so it is 1 less than or equal to 1. So hence we have proved that p dash 1 is less than or equal to 1. Okay. All right, so I hope it is clear. Have a look. All right, thank you very much everyone for watching this, and subscribe the channel and use this code Jeet1 to get 10% discount in all right, subscription, Unacademy subscription.